Hello everybody, it's an honor to be here with Professor Doya-san. Thank you. Thank you for this interview. Professor, you are in a specific domain about the brain and artificial intelligence. I let you introduce yourself.
Okay, so I'm Kenji Doya, a professor at the Neural Computation Unit of Okinawa Institute of Science and Technology. So I'm originally an engineer, but gradually became more and more interested in how the brain works. So I'm now doing my research in the intersection of brain science and artificial intelligence. Right. Yeah.
Very interesting, because your research is about the comparison between the brain and artificial intelligence impact, and you speak to me about the effect of this conscious that tomorrow AI could be have. So what do you mean with this simulation of conscious of an artificial intelligence? What does it mean?
Yeah. So today's artificial intelligence benefited a lot by learning the brain's architecture called deep learning. But still, there's a big gaps between what today's AI and deep learning can do and what our brain does. So important difference is that our brain can learn relatively small number of samples compared to today's deep neural network. We take a huge data set. So and then many people are thinking why our brain can be so data efficient. So one aspect is that our brain appears to acquire the model of the world, model about how your body responds to your muscle command, how the physical system changes, and how your friends and other people behave to your action and rules. So using such knowledge or the model, you can run a simulation in your brain before actually moving your body or saying something to your friend. So such a capability of running a simulation may be a very important aspect of our brain to realize efficient learning and adaptation. So we are very much interested in how our brain can run such a simulation which we call mental simulation. So today's computers are very good at running simulation once we write down the equations. But our brain can capture the right variables and the right dynamics based on sensory motor experience. How such learning is possible, and also how such a simulation forward into the future or backward into the past is controlled. That's a very fascinating topic in the brain science today. And if we better understand how we run mental simulation in the brain, maybe we can extract some kind of knowledge to implement in the future AI agents. That's our idea.
Thank you very much, Professor, for this insight. And we understand that better, we understand the brain, and better we can both control and let the AI becoming autonomous.
Yes. So another important difference between today's AI and the human or animals is that today's AI is just created by outside. So the animal and humans evolved in itself. So it can have its own goals and desires, and then find out a method to achieve those goals. And reinforcement learning is a way to let the AI agent to achieve certain goal specified by the human designer. But in the future, the AI agent themselves can find out more higher level goals to become more autonomous. But that can also have a potential danger, like AI agents by pursuing their own goals sometimes may harm or interfere with humans. So giving an AI agent to have the capability to understand how his or her action affects the other people and how other people evaluate those actions such a social capability is quite important for the future AI agents to be autonomous.
Thank you very much for this interview. Thank you. Okay. Bye. We had just in OIST University, and it's important to let all the public know. Thank you.
Thank you.